Hello, so today we'll be implementing dynamic batching into our LLM server. Batching multiple prompts would mean different sequence length. So we need to pad the shorter ones from the left end. Now the interesting part is our attention mechanism needs to know which position are we padding. That is why we need to add an explicit attention mask parameter to GQA or forward function in our attention layer. We'll start with implementing build attention mask function that stacks two masks together. The causal mask built with torch.tryu prevents attending to future tokens, and the pairing mask block attention to paired tokens. Fortunately, we just need to add them together. Let's move to generate batch function. We hand it a list of prompts, set left padding so they all end at the same position, tokenize everything at once, create the combined attention mask, and then run one forward pass with the entire batch, for which we get the logits and cached key value. Moving to decode loop, for every sequence, we sample the next token using temperature and top P. Here, we need to re-implement or extend the function of top_fee for the entire batch size. We then keep track of which sequence is finishing using the done variable and iterate until they are all done or we hit the maximum number of tokens. Now we need to wire this into our server. The inference worker currently pulls in one request at a time, and we are changing that. Instead, it trains multiple waiting requests from the queue, batches them together, and send them to generate batch. So, we drain the queue up to max batch request, then we check, are they all using the same model? If yes, we call the run batch function and then simply zip entire generated result back to its corresponding future. Otherwise, for the scenario of mixed models or prefix cache, we gracefully fall back to sequential execution. Time to say if all this work actually paid off. Let's fire 5 requests simultaneously using a test script and watch them batch together on the GPU. The server drains the queue and run one forward pass with a batch size of 5. However, the implementation wasn't really correct in its naive form that I implemented in the very first scenario. For example, I didn't really implement the build attention mask very carefully and there was some NaN being passed into the code base. I tried the attention mask through entire forward pass and tested once again. With the 5 concurrent requests hitting the servers simultaneously,